Hey, welcome back. Today we are going to be taking a look at Continuity Day 3, the hard day. You've all been thinking it's been pretty easy. Welcome to today. All right, the first one comes from an AP exam. This is actually an application of continuity. And we're given the function, the square root of x 25 minus x squared. And we want to know if g of x, which is defined by f of x from negative 5 to negative 3, and x plus 7 from negative 3 to 5, is continuous at x equals negative 3. And they're telling us to use the definition. Well, we've been talking about this, and we know the definition. It's pretty darn simple. Here it is. 1, does the value exist? 2, does the limit exist? 3, set them equal again. That's what we call continuity. There we go. Continuity in a nutshell. Let's do this. All right, so to show that a function is continuous at a point, we first have to show that that the value exists at that point. So 1, we're going to test a value at negative 3. And if I plug it in, it's going to be on the top one, f of x. So that's going to be using our square root of 25 minus 9, negative 3 squared, and that's just going to give us 4. 2, we want to make sure that the limit exists. Now this is a two-sided limit here. So we have to be very careful. So we want to make sure we look at the left-hand limit and the right-hand limit. So the limit as we approach negative 3 from the left, we want to see that that's equal to the limit as x approaches negative 3 from the right. The left is going to put us on f of x. That's our square root of 25 minus x squared. The right side is going to put us on this x plus 7 right there. If we substitute in, we already know that this side is going to equal 4. Our other side, if we plug in negative 3, we also get 4. And that's a true statement. So we know that the value exists. We know that the limit exists. So now we just have to make sure that they're the same. And yeah, they are the same. 4 does equal 4. The limit here is approaching 4. The value is equal to 4. So now we can say our answer. Therefore, f of x is continuous at x equals negative 3 because, and we're going to define it, the value at negative 3 equals the limit as we approach negative 3 of our function. And there we go. That's it. Very easy. Easy 3-4 points on any quiz, test, AP test, whatever. All right. So here, how do we use continuity? Big time on the AP. All right. This one can get kind of tricky. We want to find K, A, and B such that the following functions will be continuous at the given C value. The key word being continuous. When we talk about continuity, they're telling us to use our definition of continuity. And what they mean by saying use the definition of continuity, what they're telling us right now is that we have to show that the value exists and that the limit exists and that they're equal, but we're in luck. I know the value will exist here at negative 2. So I don't have to worry about showing the value. I'm not trying to prove it's continuous. That's different. I'm using continuity to do it. So I don't have to show that the value will exist like we did up on our warm-up. I just have to know that the value will exist. What we're really going to do here is we are going to check to see if the limit exists. And this is where it is. We have to check the left-hand limit and make sure it's equal to the right-hand limit on these. So let's take a look at example number 1. Now, everybody can pause, and you know the answer here is going to be negative 1/2. You can solve that really in your head. Most of you have already done it by now. But that's not what they're looking on the AP. What the AP wants to see is, how do we get this? And that's where our limit comes in. We are going to take the limit, because again, it's telling us to use continuity. So we have to use the limit as x approaches 2 from the left. Set that equal to the limit as x approaches 2 from the right. Now, our left-hand limit, that's this top one up here, and there's our right-hand limit. because it's greater than 2. So on the left, we're going to put this x plus 3, and on the right, we're going to have this kx plus 6. And now I can solve it. Plugging in 2, we get 5 equals, plug in 2 here, 2k plus 6. And I can solve it. K is just a negative 1/2 for us. And there's our limit right there. There's our answer. Now, be careful. If you don't put the limit and you still get that, you're going to lose a lot of points on the AP and in class. You want to make sure we're testing a limit process here. All right. Question 2. Question 2 is a little bit different because now we have 2 variables to find. We want to find A and B. And for A and B, what we want to do is we have to use 2 equations. Because if we have 2 variables, means 2 equations. We're going to come up with a system. So if I notice, if I only look at the first 2, there's this huge break at -1 right there. That's where they break up. So I know my first limit, I'm going to check at -1. My second limit, I'm looking at 3, where the next 2 kind of break up. So I am going to do, for the first one, at -1. And I'm going to write out my limits. The limit as x approaches -1 from the left equals to the limit as x approaches -1 from the right. From the left, we're going to be on this ax plus 3. And on the right, we're on x plus b. Plugging in the -1 for x, I get negative a plus 3 equals to, plugging the 1 over here, -1 plus b. And if I simplify this, I can bring the a over, I get a plus b equals to 4. So there is one of my equations. So how do I get the second equation? Well, I use the same thing for 3 now. Okay, so let's do that for 3. The limit as x approaches 3 from the left equal to the limit as x approaches 3 from the right. On the left, there's my left, x is less than 3 right here, we're on x plus b. On the right, x is greater than 3, that's going to be a 3xa plus b, or sorry, minus b. There we go. Plug in the 3 here, we get 3 plus b equals to 9a minus b, and when we simplify here, we would get 9a minus 2b, or not 2b, get it, equal to 3. And there's our second equation. Now again, if you don't have the limits, we're not going to give you credit. You got to have those limits there. Don't lose a lot of points because you don't want to be the limit person. And now we're going to solve this system of equations here. A plus b equal to 4, 9a minus 2b equal to 3. And you're just going to solve it, however you want to solve it. And what you wind up with is a is 1, b is 3. And there's your answers. Now, most everybody will be able to get to this part pretty easily. But without the limit, you're not going to get credit. So make sure you show those limits on there. Show your limits. Or I guess you could say, know your limits. That was funny. All right, let's try the next one here. Oh, man. Oh, man, this one looks pretty hazy for us, okay? So let's get busy with this one. All right, here we go. Same thing for like number 2. I got 3 equations here. So I want to find the values for a and b so that this would be continuous. So what do I have to do? Well, I have to look at where they break up. Ready? So the first breakup occurs at 2. Pretty simple. That's for the first 2. So my first c value is going to be for c equals 2. And I can write that out. The limit as x approaches 2 from the left equals to the limit as x approaches 2 from the right. Now on the right, we're going to be on this one. ax squared minus bx plus 3. Don't panic just yet. It looks ugly, but this turns out really nice. The other one over here is this x squared minus 4 over x minus 2. Now that one's not so nice for us, because if you remember, this is indeterminate. So I have to factor that one. The limit as x approaches 2 from the left, this becomes x plus 2. x minus 2 over x minus 2 here. Cancel, cancel. And if I plug in the 2 now, I'm going to get 4. Whew, that's a lot of work. Over here, I can just substitute in, and that's going to become 4a minus 2b plus 3. So I'm going to write that out here. 4a minus 2b plus 3. And if I simplify it, I get 4a minus 2b equal to 1. And there's my first equation right there. Not my answer, but my first equation. Now I find out where the next break occurs. That's easy. It occurs at 3. So I'm going to go and solve it. Let me fill the line there. So I'm going to do my limit now at 3. C approaches 3. The limit as x approaches 3 from the left, that's going to be this ax squared minus bx plus 3 equal to the limit as x approaches 3 from the right, which is our 4x minus a plus b. All right. Very simple. Remember, because this is pointing greater than, that's heading to the right. This is less than, that's heading to the left. Plugging in the 3, we get 9a minus 3b plus 3. Plug in the 3 here, and we get 12 minus a plus b. And we can clean this up. This becomes 8a minus 2b, whoops, where'd that go? There we go. Minus 2b, and bring the 3 over, equal to 9. And there's your second equation. And then you're just going to solve it. 8a minus 2b equal to 9. 4a minus 2b equals to 1. If I multiply the entire bottom by a negative, that's going to become 4a, 2's cancel, equal to 8. So a is 2. And once I have a is 2, I can plug it into either one of these. So I can go, I'll plug it into 4a. That becomes 8 minus 2b equal to 1. Negative 2b equals to, what's that, 7. So b is what? Negative 7 over 2, I hope. Not too bad to do. All right, so I hope you enjoyed this video. And if you have any questions, please please let me know, okay? Hopefully that answer is right there. Yeah, did see the error. Doggone, we subtract the 8, that should become a negative 7. Make that a positive. I'm going to hear that in the comments, I promise. All right, you guys enjoy the day. I'll see you later. Bye-bye.